Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, you can visualize this as one block multiplying with another block. So it's like me asking you to sketch a graph of y equals x sine of x. So here you got one block times another block. This sine of x here is going to look like this. It's going to look something like this, and then y equals x looks like this. And then if you look at this at a here, wherever that may be, this block here would be 1. This block here would be 1. 1 times a, it would be a. So this point here will jump up to here. This point here will jump up to here. This point here will jump up to here, and so on. And then this point here will jump down here. This point here will jump down here. Overall, your graph will look something like this. So you can see that it's getting bigger and bigger and bigger. So this is like your x here. This is like your x here. Well, you can see that this graph here will look something like this. Hang on, it will look something like this. So it's just going to get bigger and bigger and bigger. It diverges basically. This sequence will diverge. Okay. So next question. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, try and have an understanding of what's going on. Let's just say n equals 9. Let's just select 9 randomly, just so that we can understand what's going on. Let's say this is 9, and this here is 9. So 4 to the power of 9 is 4 times 4 times 4 times 4, 9 times, and then over 9 to the power of 4. So it's really 9 times 9 times 9, 4 times. The question is, which one will be bigger, the numerator or the denominator? Well, if you look at this here, this is already 16, which is bigger than this. This is 16 bigger than this. 16 bigger than this. 16. You should have a gut instinct that the numerator should be much bigger than the denominator. So let's just try and evaluate this now. So your gut instinct should tell you that, well, the numerator will be a lot bigger than the denominator. So as n tends to infinity, your gut instinct should tell you that it's going to go towards infinity, because the numerator is just going to get bigger and bigger, much faster than, well, your gut instinct should tell you that. But let's just look at it. Let's just try and evaluate it. So looking at this, we are trying to find out the limit of this sequence as n tends to infinity. So here you've got one thing over another thing. As n tends to infinity, this thing here is going to be infinity. It's heading towards infinity. This is also heading towards infinity. You've got infinity over infinity, so you can apply L'Hopital's rule. So L'Hopital's rule, differentiate it will then give you this. Remember, to differentiate 4 to the power of n, set y to be this, take the natural log of both sides. Well, you should know this by now. If you differentiate this, it will give you natural log of 4 times 4 to the power of n. So when you differentiate this, it will give you, by the way, you should already know this. So when you differentiate this, it will then give you this. Differentiate this, that will then give you this. So now that you're here, check it again. As n tends to infinity, this thing here is going to go to infinity, and then this thing here is also going to go into infinity. So here you've got an indeterminate form, so you can apply L'Hopital's rule again. So applying L'Hopital's rule, differentiate this, that will then give you this, and then differentiate this, that will then give you this. So now that will then take you to this stage. So now check it again. As n tends to infinity, this whole thing here is going to head towards infinity. This thing here is also going to head towards infinity. So you can apply L'Hopital's rule again. And if you keep on doing it, so you've got one thing here, and then differentiate this, that will then give you this. But eventually, this thing here is going to become a constant. And if you keep on repeating the process, this thing here is always going to have this 4 to the power of n. Well, 4 to the power of n looks like, well, this thing, if you keep on applying L'Hopital's rule, eventually this thing here will come to a constant, and then so you're going to have something containing 4 to the power of n over a constant. So you know that this thing here is just going to head towards towards infinity. So as a result, you can tell that this thing, this sequence will head towards infinity. And if you get a graph plotter and plot this, you can see that it heads towards infinity. Okay, so this sequence here diverges.